Yeah, just a second. I'll turn it on.
By the time, Vidal, please tell me that do you have any upcoming exams in your school? Do you have any upcoming math exam?
Yes, ma'am.
No, no.
On September.
Yeah. So can you tell me the syllabus for exam? After your camera is still off, child. What is wrong?
1 second.
The number system, polynomial, coordinate geometry, linear equation, equilibrium geometry, and lines and angles.
Okay, 1 second. You have number system. Then you have coordinate geometry, and then
Polynomial,
polynomial. Next.
linear equation,
Okay. Next. Next.
geometry,
What geometry? Coordinate geometry I have written.
yes,
Lines
ma'am.
and angles. Any other chapter from these?
Lines and angles are there.
Okay, fine. This much.
One more, totally six chapters that meant accrued geometry,
What are you saying, Vidal? Please say again a little loudly.
accrued geometry means spelling EUCLID.
Okay, Euclid's geometry. Okay, fine. Anything else? This much.
Ma'am,
Okay, and Hafsa, do you have any upcoming exams?
No, no. The only exams we have are after the vacation,
Yeah,
and
you
we didn't get the
understand. So
portion for it.
you didn't get the portion for that. Okay. And what all chapters have been completed in your school?
We completed coordinate geometry, linear equation to variables, lines and angles, Heron's formula, statistics, and polynomials.
Heron's formula, statistics. Okay, and
Polynomials.
polynomials has also been completed. Okay, but then when is your exam at?
after the vacation, September 18.
Okay, in September you have. Okay, fine. And what about Abdullah? Abdullah, please put on your camera quickly. Put, yes, Abdullah.
Yes, ma'am.
Can you tell me the portion for your exams? Any upcoming exams if you have and the portion for that?
Ma'am, they didn't send any portions till
Okay,
now.
and okay, so what about the lessons that have already been completed in your school?
Heron's formula, useless geometry.
Okay, so you have Heron's
Uh,
formula, Euclid's geometry, and
yeah, that's it.
just two lessons have been completed.
Yes,
Other,
ma'am.
other nothing.
The rest, this polynomial inequations, coordinate geometry, they're already done.
Polynomials, linear equations, and coordinate geometry also they've already done. Okay, children. So now we have these upcoming chapters that we have to do. Children, we haven't done number system also in the class, right? So I was thinking let's start
Mm,
with number system. Let's quickly complete this lesson so that at least
okay,
we are
Okay.
done
ma'am.
with the basic starting lessons of a syllabus and then we can move on. Right, children? So is everybody fine with number system?
Yeah, ma'am.
Yes, ma'am.
Okay. Number system, yeah, we didn't do only. Okay, children. So in number system, first of all, you need to differentiate what are the different kinds of numbers that we have on the number line. Okay. So now, if we talk about number system lesson, so first of all, children, you need to very carefully know what are the different kinds of numbers that we have. So if I talk about a number line, so I have a 0 in center. And if I start moving towards the right hand side of 0, I have all the positive numbers with me. Like I will have +1, +2, +3, +4, +5, and so on. If I start moving back words from 0, so I have negative numbers like -1, -2, -3, -4, -5, and so on. Right, children? Now what happens? If I start my counting from 1 onwards, okay, if I'm starting my counting, like I count from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on up till infinity. So these numbers are known as natural numbers. They're known as natural numbers. If I start my counting from 0 onwards, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up till infinity, then they are known as whole numbers. But if I'm also including negative numbers, like negative numbers as well as the positive numbers, then they are together known as integers. So integers are the negative numbers also and the positive numbers also. For example, -1, -2, +7, -10, +11, etc. Okay. Natural numbers are like 1, 2, 3, 4, 5, 10, 11, anything. What are whole numbers? Whole numbers are all the natural numbers including 0. Like if I ask you a 0, is it a natural number or a whole number? You say, ma'am, 0 is a whole number. Okay. 1 plus 1 is a natural number also. It's a whole number also. It's an integer also. So these are some of the classifications of numbers that you must know. Right. Now what about rational numbers? What are rational numbers? Rational numbers are basically the numbers that are lying between the integers. Rational numbers lie between integers. For example, I say between 1 and 2. Between 1 and 2, I have a number that is 3 by 2. That's 1.5. So 3 by 2 is what? 3 by 2 is a rational number. Right, children? 3 by 2 is a rational number. Right? So now let's suppose the question says, are the following statements true or false? The first one is every whole number natural number. The second is every integer is a rational number. Third question is every rational number is an yeah. So we have every rational number is an integer. Okay. So now what you will do? Every whole now children tell me every whole number, is it a natural number or not? Is every whole number a natural number or not?
False. No, ma'am.
Why no?
You have class.
Whole number means 0 is included.
Yeah, 0 is included and 0 is a whole number and 0 is not a natural number. So you will say false. And why? The reason is 0 is a whole number but not natural. Right? The next question is, every integer is a rational number. You think every integer is a rational number? See children, what were integers? Integers are, for example, I say 2, I say 3, I say -4, I say -7. Now rational number, what were rational numbers? Now rational numbers are the numbers that are like in the form of numerator as well as a denominator. So if I have to define rational number, I can say rational numbers are written in the form of p by q. Okay, where p and q are not equal to 0. Now what happens? Can I write 2 in the form of p by q? For example, yeah, I can write 2 by 1, right? Where 2 is p and 1 is q. 2 is the numerator and 1 is the denominator. So is every rational number is every integer a rational number? True or false? Tell me children, true or false?
True.
True. I can write every integer as rational number. Let's say -7. So -7 I can write as -7 by 1. Let's say -4. I can write -4 as -4 by 1. Let's say 3. 3 I can write as 3 by 1. So all of these are rational numbers now. So every integer is a rational number too. Okay, every rational number is an integer. Do you think every rational number is an integer?
No,
No. Why no?
No.
Give me the reason.
because positive 1 by 3, like that, those are between two numbers.
Exactly. Let's suppose a situation where you have plus 1 by 3. So plus 1 by 3 is a decimal value when you solve it. And decimals are not integers. Integers has to be a proper whole complete number in itself. So that is not a decimal number now. So 1 by 3 will give you a decimal number that's not a integer. So every rational number is an integer false. So children, look at these statements and tell me, do you understand the solutions or not? Do you
Yes, ma'am.
understand? Okay. So
Yes,
now
ma'am.
we come to the example 2, and it asks you find 5 rational numbers between 1 and 2. So what you will do? Between 1 and 2, you have to find 5 rational numbers. So first of all, children, I know rational numbers are written in the form of p by q. So first of all, my basic step would be I want to make 1 and 2. I want to write them in the form of p by q. I should have a numerator also, a denominator also. So what can I do? I take the first number. What is my first number? 1. You take 1 and you multiply it with 6 by 6. Now, why am I taking 6 by 6? Children, you always take the one number higher than the given in the question. Like in the it's given 5 rational numbers. So you will multiply with 6. If it was given 7 rational numbers, you'll multiply with what number? If it was given in the question, find 7 rational numbers. So with what number will be multiplying?
7.
I just told you one higher number.
Also 8.
So 8 by 8, children. If it's given 5 rational numbers, you multiply and divide by 6 by 6. Children, are you understand me? So what will this give me? This gives me 6 by 6. What is the other number? 2. You take 2. You multiply it with 6 by 6. What is my answer? 12 by 6. So now I have converted 1 as 6 by 6 and I have converted 2 as 12 by 6. Now can you tell me the numbers between 6 by 6 and 12 by 6? I have 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. So how many numbers do I get? Do I get 5 rational numbers or not? Do I get 5 rational numbers or not? Children, you are not at all responsive. But then what happened? Why is your mic off? And even Abdullah,
Yes, ma'am. I can.
what's the issue? I'm constantly asking you, you're just sitting idle, no response, just sitting randomly. Can you please respond? If you understand, then tell me yes. If you don't understand, then tell me no. At least I should be able to know whatever I'm teaching, are you understanding it or not? Do you understand this question, children?
Okay, ma'am.
Yes, ma'am.
Okay. So now we come to one more question of the similar type. The question is, find six rational numbers. Six rational numbers between 3 and 4. Okay. So what you will do between 3 and 4, how will we find rational numbers? How many numbers do I have to find?
6.
6. So with what number will I multiply and divide 3 and 4?
7,
7 by 6.
7 by
So I
7.
will write 3 can be written as
7
3
into
into
3 by
7 by
4.
7 and 4 can be written as 4 into 7 by 7. So that gives me 21 by 7, 28 by 7. Right? So thus the required rational numbers are now between 21 and 28. How many numbers do I have? 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, and 27 by 7. So these are my required numbers, right? Understood? So children, you can copy this one.
Yes, ma'am.
This question, please copy me and tell me if you copy. Children, please respond once you've copied also. Okay?
Yes, ma'am.
And with and Hafsa.
No, ma'am. Wait, ma'am, could you scroll?
Yes, Hafsa.
Could you scroll back up? I'm not done.
Okay, please copy it quickly. If we have a memo also in the class, memo, if you hear me, please put on your camera quickly. Memo, do you hear me?
Yes, ma'am.
Yeah, put on your camera side.
I'm done.
Okay. Yeah, memo, please put on a camera so that we can start with you as well. Alright, so we'll have a quick revision in 2 minutes. Remember, we have started with this lesson number system. Okay, and number system I explained the different kinds of numbers. So do you know what are natural numbers, whole numbers, and integers? Any idea?
Yes, ma'am.
Yeah, so what are natural numbers?
They are the numbers, but without zero and negative numbers.
They are the numbers that start from 1 onwards. Right, then what are whole numbers?
The numbers that start from zero.
Yeah, and integers are the set of negative numbers as well as the positive numbers, right? Then we studied that these were the 3 questions that we discussed. Every whole number is a natural number? No. Why? Because 0 is a whole number, but that's not a natural number. Every integer is a rational number? What do you think? True. Why true?
Because in integer they are natural rational numbers. No natural.
Rational numbers are basically the numbers that are written in the form of p by q. For example, I say 2 by 3, 5 by 3, minus 7 by 4. So they are in rational numbers. But why can I call integers also as rational number? Integer is just minus 4 or just plus 4 or just plus 7. How can I call it a rational
Ma'am,
number?
because integers can be in the form of p by q,
Yeah, how can they be
like
in the form of p by q? Like I can
like
put,
minus 1 by 1,
yeah, I can put 1 as
minus,
the denominator for all the integers and I can get a rational number. Like I say 4, so my answer becomes plus 4 by 1. If I say minus 5, my answer becomes minus 5 by 1. So every integer is a rational number, true. Every rational number is an integer, false. I can have numbers, rational. See, not all rational numbers are integers. Only a few rational numbers can be integers. If I have, let's suppose 5 by 2, so 5 by 2 is 2.5. 2.5 is not an integer. If I have 10 by 5, so 10 by 5 is 2, which is an integer. Right? So some of the rational numbers can be integers, but not all. So every rational number is an integer. That's Then we practice these questions whenever you have to find rational numbers between two integers. So let's suppose you have 1 and 2, and I say find 5 rational numbers between 1 and 2. So what you will do is, the question says find 5. So you will take one higher number than 5. So one higher number than 5 is 6. And now you multiply and divide both of these integers with 6 and 6. So I get 6 by 6 and 12 by 6, and just write the numbers between 6 by 6 and 12 by 6. Okay, tell me, do you understand this?
Yes, ma'am.
Now similarly, we have just practiced this question also, like between 3 and 4, what you can do. So I can write 3 as 21 by 7 and 4 can be written as 28 by 7, and my answer becomes all of these numbers. Right? Now let's suppose the question is find 5 rational numbers between 3 by 5 and 4 by 5. So what you will do, first of all, you take the first rational number, that's 3 by 5. And now I have to find 5 rational numbers, so you multiply it and divide it by 6 by 6. What do you get? 18 by 30. Then you take the other number, 4 by 5, multiply and divide with 6 by 6, 24 by 30. So what are my required rational numbers? Required rational numbers are 19 by 30, 20 by 30, 21 by 30, 23 by 30. So I have my 5 rational numbers. Right? Children, this is the way that you're supposed to solve these questions.
Yes, ma'am.
Next question can be, state whether they are true or false. Every natural number Right. So children, these are the three questions. First one is every natural number is a whole number. Then every integer is a whole number. Then every rational number is a whole number. So you have to write true and false, and also write supporting statements as your answer. Okay, you just don't have to write okay true or false. Write supporting statements. Why true? Why false? Okay.
Done, ma'am.
Okay. What about others?
Done, ma.
Yes, ma'am.
Yes, children. Done. So the first is every natural number is a whole number. True or not?
True.
True. Okay. Why? Because you can give a supporting statement 1, 2, 3, 4, 5. All of these are natural numbers also, and their whole number is there. Every integer is a whole number.
False.
Why?
False,
False.
false.
Because integers
Negative
also
number.
have negative numbers, but then whole number doesn't have negative.
Yeah, negative numbers. So you can write minus 5 is an integer, but not a whole number. Right? Every rational number is a whole number. Is every rational number a whole number?
False.
False.
Why? Why false? Hafsa, why is your camera off? Why false? Then give me a supporting statement as well.
Because two.
Because
Because 2 or 3 is a real number.
because 2.
Can be a can be rational too.
Can you speak again, Adele? A little slowly. Please speak again.
Because 2 is a real number, but it's not a rational.
Real number and rational numbers. No, Adele, you are confused. I did not teach you real numbers till now. Right? And 2 is a rational number also. It's a whole number also. That's not the correct explanation. Who will give me an example for this? Why is it?
Okay, ma'am. Huh?
Yes. Nobody knows. See, every rational number. Can you tell me any rational number?
Ma'am, for because rational number cannot be whole numbers because 1/3 is not a whole number like that.
Okay, that's good. Because example can be 1 by 3 is a rational number but not a whole number. But now we can also have certain rational numbers which are whole numbers. For example, I told you 10 by 5 becomes plus 2. Plus 2 is a whole number as well. But the statement says every rational number. So every rational number is not a whole number. So that is why the statement is false. Children, let's suppose I make a test and I say, instead of every, I write some rational numbers are whole numbers also. So then is it true or false? Some rational.
Ma'am, can you repeat?
I'm saying, what if I write the statement as some rational numbers are whole numbers also?
No, that's false.
Right? Some rational numbers can be whole
Yeah,
numbers.
some rational numbers can be. Yeah,
If
that's
you
true.
put in every rational number, then it's not. Okay. Next question you have is 0 a rational number? Can you write it in the form of P by Q, where P and Q are integers? So first of all, tell me, is Q 0 a rational number or not?
Yes.
Yes. Okay, Mema says yes. So, Mema, can you tell me why is it a rational number? What are rational numbers?
The numbers which are in P by Q form and it can be negative and positive are rational numbers.
Okay, fine. So, what about 0? 0 is not in the form of P by Q. Then why is it a rational?
Ma'am, because 0 divided by 1 is 0. That's why.
Oh, very good. Yeah, so you can say yes, 0 is a rational number as it can be written in the form of P by Q, where Q is not 0. Example, 0 by 5 is 0, 0 by minus 4 is 0, 0 by 3 is 0. Okay, remember these things. The definition for rational number, see, this is the definition for rational number. Noted. Rational numbers are the numbers that are written in the form of P by Q, and Q should be not equal to 0. For example, if I say 5 by 0, is it a rational number? Is it a rational number or not?
Ma'am, can you repeat?
I'm asking you, is 5 by 0 a rational number or not?
No, it's not a rational number because
No.
Q should
Q
not
is
be
equal
equal
to
to
0.
0.
Exactly. Then P can be 0, but Q should not be equal to 0. So actually, this is a non-defined value.
Yes.
It's a non-defined value, so it's not any kind of number only. Whenever you're dividing anything by 0, now you cannot divide anything into 0 parts, right?
Yes, ma'am. Yes, ma'am.
So that's non-defined value. So these are some of the basic. Children, this chapter is very important for building up your basic. Okay, sometimes in higher classes also you might come across several questions that are very easy, but you don't know the basic only, like what kind of numbers, how to differentiate them, and everything, right? So just be very careful in this type of questions. Children, have you all noted these statements? Noted this question?
Done.
No, no, no,
So,
go back.
children, now done, right, everybody?
No, no.
Yes.
Hafsa is doing. Hafsa, copy quickly. You are sitting most of the time, and then at the last you start doing.
Done.
All right. So now we come to the next topic. So this was all about the first exercise. Now we come to irrational numbers. Now what are irrational? So let's see. It's the exact opposite definition of rational. So irrational numbers are n numbers that cannot be in the form of p by q where okay, so this is the definition for irrational. Now, what are some of the examples of irrational? Now, I told you they cannot be written as p by q format. Now, let's suppose I say under root 2. Now, under root 2 cannot be written as a decimal. It can be written as a decimal number, but it cannot. You cannot change it into a fraction form, right? So that is why root 2 is not rational. All the root numbers, in fact, like root 5, root 7, okay, all the root numbers that are not perfect squares. Now you cannot say, ma'am, root 16 is irrational. No, root 16 is rational. Why? Because root 16 is equal to, how much is root 16 equal to? So nobody knows root 16 is equal to what? Root 16. 16 is a perfect square or not?
Yes,
So
ma'am.
that's, yes, yeah, Vidil. So of which number is it a perfect square of?
Or
4. Well, so why are you not answering, child? If you know the answer, please answer me in the class. Root 16 is 4. Vidal, you are not responsive. Amongst all the children, you are least responsive in the class, and that's not good. I have to ask you many times and then you answer. Root 16 is 4, so that's why is root 16 a rational number or not?
No.
Yes.
Who is this here? Children, yes or no? And tell me with reason now. Root 16 is rational or irrational?
It's
Ma'am, it's
rational.
rational.
It's rational, yes. And why is it a rational number? Because I get the answer as 4. Yeah, and 4 can be written as 4 by 1. So root 16 is actually a rational number, right? Are you understanding this? Okay,
Yes,
let's
ma'am.
suppose the value of pi. Now, even you know the value of pi. Pi is equals to 22 by 7. Even 22 by 7, you keep on dividing it and you keep on getting decimal numbers. So that is why it's also irrational. Right? So, children, now we'll move to the next exercise. You have next question is locating root numbers on the number line. Okay, before that, we have some more basic questions. The question is not question or concept. What are real numbers? You must have listened to this term real numbers. Will anybody tell me what are real numbers? Any idea? Okay, children, see what happens. Real numbers are basically. Yes, Vidal wants to say something.
Wait, ma'am, can I rejoin? Your voice is cutting.
Yeah, Hafsa, quickly rejoin. Student, now real numbers we have is basically 1 second. Okay, so real numbers are basically all the rational numbers as well as all the irrational. They together form the real numbers. Okay, so all the irrational numbers as well as all the rational numbers will give you the set of real numbers. Now, real numbers are basically, now you see, I taught you that we can plot all the rational numbers on the number line. Now, in a similar way, we can also actually plot irrational numbers also on the number line. Okay, so on the number line, we have a unique point. For all the real numbers. Because we are able to plot rational numbers also as well as irrational numbers on the number line. We've studied rational numbers plotting in junior classes. Okay, like plot 1 by 2 on the number line, 3 by 2 on the number line, etc. We used to study that in 7th grade. In this class onwards, we will be starting with plotting irrational numbers on the number line. Okay. Now, let's start with the next exercise. The question says, plot 2 on the number line. So, do you have a scale, compass, and pencils with you? Can you all go bring them quickly? Bring a scale, compass, and a pencil. And also bring a D scale. D scale is basically a protractor.
Okay.
Bring these 4 things quickly. Abdullah, you already have them. Show me your scale, compass, and protractor, and a pencil. Show me all these
Yes,
4
ma'am.
things. Okay, now everybody has these 4 things.
Yes, ma'am.
What?
Bidel and Hafsa.
What do
Hafsa
you
also.
speak this language? What are you asking for, mom? Because I want to see that.
Hafsa, are you saying something?
Yeah, ma'am, what were you asking?
I asked you to bring a scale, compass, a protractor, and a pencil.
Okay.
Quickly bring them. So then by the time you can arrange your pencil in your compass.
Ma'am.
So children, now focus on the board very carefully, and you will just keep on doing the steps as I tell you to do. First of all, you have to plot root 2 on the number. So what you will do, you draw a straight line, okay, and you mark a point 0 on it, right? Draw a straight line with the help of a scale and mark a point 0 on it. Done?
Yes, ma'am.
Now children, what you will do with the help of your scale. Now the 0 mark on your scale should align on this 0. The 0 mark on your scale. Okay, you have a scale, there is a 0, 1, 2, 3, 4. So 0 on the scale should align with this 0. Keep it over this line and the 0 should align with this 0. And now you take, it's your choice now. You can take 1 centimeter also, you can take 2 centimeter also, you can take 3 also, 4 also, anything you can. Let's suppose we are taking 2 centimeter. So now every time 2 centimeter will be equal to 1 unit. Just remember this. I have taken 1 unit as 2 centimeter. So you mark a point 2 centimeter and call it A. This should be 1 unit. This is 1 unit. This is 2 centimeter. Okay. Everybody has a point 0 and a point A.
Yes, ma'am.
Now what you will do, the protractor that you have, the D scale basically, you keep it over here and its center point should align with this A. Its center point should align with this A. You keep it over this line. Center point of the, see, this is your D scale. It has a center point over here. So this center point should be over this A. Okay. And now you mark 90 degrees. So where is 90 degree? Exactly above it. So now you mark the point 90 degree exactly above it. Make a point over here, 90 degrees. Okay. Everybody has marked 90 degree. Now you remove the protractor from the notebook and you take a scale and draw straight line. Draw straight line. Okay.
Done.
Draw on a straight line.
Yes.
Ma'am.
This was the point. Now children, what you will do is, see 1 unit, this much was 1 unit. Now again you take your scale and what was 1 unit? 2 centimeter. So again from point A you take 2 centimeter and make a point at 2 centimeter. Again take 2 centimeter, make a point here, mark it as point B. From A take 2 centimeters. This much is also 1 unit now. And now with the help of the scale, join point O and point B. Join point O and point B. Everybody has this kind of figure now, O, A, B and a triangle kind of figure.
Yes, ma'am.
Now what you will
Yes,
do
ma'am.
is, you take your
I have
compass,
a-
you take a compass and keep the needle of the compass on point O. The needle should be over here on point O. And your radius of the compass should be this part. This should be the radius.
Yes, ma'am.
Right? You take this much as the radius. Now children, you do not change the place of the needle. Instead, you, with this much point only, just keep your needle over here only and now you cut it at this point. Cut this line, the straight line, you cut it at this point and the radius is how much? OB. Okay. Children, done this much?
Yes, ma'am.
Ma'am.
And mark this point as T, let's suppose. So this point right here is equal to 2. Alright?
Yes, ma'am. Then,
Everybody
ma'am,
got
how
it?
are we supposed to know that the answer is correct? Like,
See, uh, First tell me, did you get this kind of figure or not?
Yes, ma'am.
See, Umema, our answer is correct. Why? Because tell me one thing. Do you know the Pythagoras theorem?
Yeah.
You know the Pythagoras theorem? The Pythagoras theorem states that the hypotenuse square is equal to base square plus perpendicular square. Right? What is my base? That's 1 unit. So 1 square plus, that's again 1 unit. 1 square should give you hypotenuse square. So hypotenuse square is 1 plus 1. Hypotenuse square is 2 and hypotenuse is root 2. So actually this line is equal to root 2 and we are pointing out the reflection of this line on the horizontal line. The reflection of this horizontal line on the straight line is equal to root 2. Okay.
Okay, ma'am.
So everybody will show me their figure. Abdullah seems to be very chill. Abdullah, you'll only show me at the first place. Show me your figure. Quickly show me your notebook. Abdullah, you didn't draw, right? That's very bad, Abdullah. You did not draw. Umema, you show me.
Ma'am,
Yes, ma'am.